Okay, the next chapter in the first part, okay, for the market forces in the development of the city is city size. So in this chapter, we are going to look at the what are the economic forces that are responsible for the development of the cities of different size, and we are going to look at the why the city differs in the economic scopes from highly specialized cities to the diverse cities. Again, in this chapter we look into the why do the cities differ in size and scope of economic activities, where we have the small as well as the large cities, and this chapter also look at the economic forces responsible for the development of a different city size, different size of the cities. Okay, and we are going to look at the cities growing or shrinking over time and what determines the size of the city. Okay, in order to do this, we need to consider the utility per worker in all cities in a given region, and what happens when the workers migrate from one city to another until the utility per worker is equalized. The key question in this topic is how does an increase in the city size in the population will affect the utility of the typical worker, and we can see that with the benefit of size, the agglomeration economies increase productivity, where we can see higher wages in larger city. Again, the agglomeration is a mass or collection of things, and when we talk about the agglomeration economies is the benefit that comes when firms and people locate to one another together in cities and industrial cluster. However, what we can see when the city grows, okay, the higher wage is partly offset by the cost of size. This is what we call the cost of size that comes from the commuting time, where we can see an increase with the city size. We are going to have a greater density of the population, the pollution, and also decrease in leisure time. A loss of leisure time translated into the monetary loss. Okay, we can say this is the economies of scale, but the other benefit of living in a city with the city size is the facilities, such as the public transport as well as the social amenities. But costs, again, okay, long commuting hour, higher rents, house prices, pollution. These are the things that we will take into together, okay, to look at the utility and the city size. So what we can see from the previous chapter, okay, why do firm cluster these agglomeration economies from input sharing? Okay, we have the labor pooling, skill matching, and also the knowledge spillover will increase the labor productivity, and in a competitive labor market, this competition among firms will ensure that the wages reflect the labor productivity. So wages are higher in a larger city. Okay, this two table provides a simple example of the relationship between wages and city size. Okay, we look at the second column, the wage increase at a decreasing rate, and it reflecting the assumption that agglomeration economy is diminishing as the city grows. And we can always say that this labor productivity increase with the size of the workforce, but at a diminishing rate. Okay, let's assume that the only cause of population growth is longer commuting time, and suppose these commuting times comes at the expense of leisure time, and we can place a dollar figure um, on a leisure time lost to the commuting. Okay, you look at the fourth column, okay, at the table 4.2, in the commuting cost. Okay, the commuting cost increase with city size, and a doubling of the workforce from 1 million from 2 millions. Okay, doubles the commuting cost from the per worker from $5 per day to $10 per day. Okay, you look at the workforce and also the commuting cost. Okay, and doubling the workforce again, okay, from 2 to 4 million also doubles the commuting cost. So the last column shows the utility level of the typical worker for, and we define, okay, in this topic we define the utility as income minus the value of leisure time that lost from commuting, and we also assume that each person works on the 8-hour day, so income is 8 times the wage. And moving from a city of 1 million to a city of 2 million, the increase in labor time from higher productivity is large relatively to the increase in commuting costs. So the utility increased from 59 to 70. Okay, and it is also shown in the next figure. So in this figure, a move from point S to point M on the utility curve. Okay, so we can see that that it implies that the agglomeration economies are stronger than the diseconomies of scale associated with commuting. So the utility increase. However, an increase in the workforce, okay, from 2 million, from 2 to 2 million, decrease the utility. Okay, because the agglomeration economies are weaker than these economies from commuting. And from this figure, we can see that the city's utility curve reached 70 at a workforce of 2 million. Now we consider a city with a workforce of 2 million, okay, that is shown in our figure by point M. And the workers commute from different residential locations to the city production center. And the workers differs in their commuting cost. And we refer to the first axiom, prices adjust to achieve locational equilibrium. So in this case, the price of residential land will adjust to make the workers indifferent among all residential area. So this figure shows the table shows the differences in commuting generate the differences in the land rent. How differences in commuting generate differences in land rent. So we compare two workers. One lives near the production center, so he don't have the commuting cost, didn't incur any commuting cost. And the second worker lives with a commuting cost of $10. So if the worker at the center has a rent of $25, the rent for the other workers must be $10 lower, or 15. Okay, so the same logic suggests that worker 10 miles, okay, that a worker 10 miles from the city center will only pay $5 for land. And the workers are indifferent between these three residential locations because of the differences in commuting costs that are exactly offset by the differences in the land rent. But who gets the rent? From the land. Okay, so suppose that the workers own the land, and to keep things simple, assume that the land rent is shared equally among the city's workers. The average rent is $15. Okay, this is the rent paid by the workers living 5 miles from the center, and it is shown in column E. Okay, each worker earns $15 of rental income to supplement the labor income. So for the average workers that 5 miles from the city center, the land rent paid equal the rental income received. So this for the worker living at the center, the rent paid exceed the rental income, while the opposite is true for the workers living 10 miles from the city center. So the last column shows the utility for workers at different locations in the city. So we can define the utility as the labor income plus the rental income, and we minus the commuting costs and also the rent paid. So from the table, we can say that each workers earned the same $95 of total income, the labor plus the rental income. So for this locational equilibrium, the differences in commuting costs are exactly offset by the differences in the land rent paid. So workers living at different locations will reach the same utility level of $70. So a system of a city, how a region's workforce can be distributed among its cities. And the issue is whether the region will have the large number of small cities, a small number of large cities, or something between these two extremes. So to study this, the utility curve can be used when the city are not too small, positively sloped portion of utility curve generates the unstable equilibrium, and the city will not be too small in a stable equilibrium. And when a city may be too large, okay, negatively sloped portion of utility curve generates stable income, and cities may be too large in a stable equilibrium. Now we consider a region with a total urban workforce of 6 million and three possible configurations where we have 6 cities A, B, C, D, and F with 1 million workforce each. 3 cities D, E, F with 2 million workforce each, and between 2 cities E and F with 3 million workforce each. Okay, this figure show the feasibility of the alternative configuration. For example, we look at the 6 city outcome with each city housing a workforce of 1 million, and it is shown at point S. The utility in each of the 6 cities is $59, and to look at the instability of this 6 city outcome, we assume that we have a group of workers move from city A to city D. Okay, and this workforce of city D will grow and will cause the city to move upward along the positively sloped portion of its utility curve, and leads to the higher utility level, for example at the point $60. So at the same time, the workforce of a city A will shrink, and moving the city downward along its utility curve to the lower utility level, for example $58. So in other words, the movement of the worker from city A to city D opens the utility gap of $2, which will encourage more workers to move from A to D. And because of this utility curve positively sloped near point S, the migration of is we call it self-reinforcing. So we can say that the more workers who migrate, the larger the utility gap between the 2 cities, and the greater is the incentive to relocate. Okay, and we refer to the axiom 2, where the self-reinforcing effects will generate extreme outcome, and this extreme outcome is that everyone migrates from city A to city D. That will affect city A, that city A will disappear. And point L, okay, suppose there are 2 large cities, E and F, with the workforce of 3 million each. This utility level of is $68, lower than the maximum level. Let's say the migration happened from E to F, city E to city F. So the workforce in F will grow, that pushing the utility level of F lower to 67. So at the same time, the workforce of E shrink, pushing utility level upwards to 69. Okay, this utility gap of $2, we have the utility gap of $2 that, however, this utility is higher in smaller city, okay, E, than the bigger city. So the migration is self-correcting, not what we call the self-reinforcing. We assume that city A, B, and C disappear while D, E, and F grow, doubling in size. So they will reach point M. They will become 3 cities with a workforce of 2 million each at the utility level of $70. So the 3 city outcomes happen to be the optimum, where we can say that the utility is maximized. So the result of this is shown by the utility curve. With a small city, utility curve is positively sloped because the agglomeration economies are stronger than these economies of scale resulting from commuting. And the utility of the migrant increase because of their new city is larger and more efficient, and the utility of the people left behind decrease because they now live in a smaller city. So in contrast, when we start with the large city, the utility curve is negatively sloped because of the agglomeration economies are weaker than the commuting these economies. So this utility increase as a smaller city is more efficient. Now we are going to look at the specialized and diversity. So do cities specialize in a narrow set of the economic activities, and or do they generalize? That's the question that I'm going to answer in this subtopic. Specialized cities develop because of the localization economies, and diversity is developed because of the urbanization economies. Okay, we go back. What is localization economies? Occurs when an increase in the size of an industry in a city leads to the increase in the productivity of a particular activity. Okay, from the same activity. For example, here the Silicon Valley from high-tech industry, while the urbanization economies arise when in the size of the city leads to an increase in the productivity. For example, you can see Los Angeles, no dominant cities. In many other cities, for example, even KL, okay, there's no dominant industry where all the HQs, the service centers, um, the accounting firms, marketing firms, everything is like in the city. What we call is urbanization economies. But these two types of cities are complementary. We can say that they are complementary. They are serving where they serve different roles in the market economy. Where many firms, you know that many firms start in the diversities, which foster new ideas. And when they are maturing firms relocate to specialized cities to exploit the localization economies. For example, in Silicon Valley, where we can see all those specialists in IT, in software, go there. So these matured firms try to relocate to the specialized cities because of to exploit these localization economies, as stated here. And diversity foster new ideas as well as experiment and serving as the laboratory labs for the innovative firm. And we can say that the specialized cities facilitate the efficient production. However, there will be a trade-off when they want to start with the diversity. Indeed, from the diversity, there will be trade-off. The first one is there will be trade-off. There are pros and cons. With lower prototype cost, specialized city has specialized input for the process, and for the cons, there will be the higher moving cost. To search for the ideal process might require moving to another specialized city. So there will be additional costs in moving. These are some of the example. Okay, what are the pros and cons of starting from the diversity? So if the firm choose to start with a diversity, we consider the firm looking for an ideal production process for a new product, and suppose there are 6 potential processes. Entrepreneur can observe other firms using these processes in the city. So this may take 1 to 6 hours, but on average it takes 3 hours or maybe shorter than that. Okay, and once this process is done, the method, the ideal method is recognized, the entrepreneur will move to the specialized city. Now we want to answer the question, why do cities differ in size? It is because of this we are going to explore the roles of localization as well as the urbanization economies in determining the city size. We are going to look at the differences in the city by using this utility curve. This figure shows the utility curve for 3 types of cities in a regional economy. The curve on the left applies to the industry which the localization economies are exhausted with the relatively small workforce. So in this case, these economies of commuting quickly overwhelm the agglomeration economies. So the optimum city size is relatively small. The middle utility curve is for specialized city with larger localization economy and leads to larger optimum size. And the last one, the utility curve on the right, is for the city that experience large urbanization economies that generate the large optimum size. So the local equilibrium requires that the workers in the region are indifferent between these 3 cities, meaning that the workers in the 3 cities must achieve the same utility level. And we assume that the region has a total of 10 million workers. And this figure, okay, point S, we look at point S, point M, and point B shows one possible equilibrium. Okay, then the utility level And the utility level is the same in all three cities, and the workforce 1 million in three cities, okay, it is shown in the figure, 3 million in the medium-sized city and 6 million in the big cities, will add up to the regional workforce of 10 million. So we can say as we this is a stable equilibrium because each city is on a negatively sloped portion of the utility curve. Okay, that's all for this topic. The important thing is how can you relate the utility and city size, what happened when the workforce move from one city to another city, what happened to the city that they left, and what happened to city that they go. Okay, these are the things that is important in this topic. Then that's all. Thank you.